Hey, well, welcome. Thank you so much for joining us today. And we know that it's report card time, and we know there's parent-teacher interviews happening. So we have been seeing fewer people at the sessions because of that, and we understand that totally. But thank you so much for joining us. This is our second last one that we're going to be doing with you. Our last one was just really reserved for grades 4, 5, 6. And that is space, because now that's been downgraded, or not downgraded, but integrated into the 3 grades rather than just grade 6 as it has been in the past. So we will see you again once after Christmas to finish up on that session. So today we are finishing up with energy, and you're going to see some terminology that's going to have been carried forward from other grades. So that will be an important component this time round when you're considering how you might plan for this particular organizing idea, because you are going to have to really pay attention to what are the transferable things that came from grade 5. And there's quite a few linkages there. We'll also take you back and give you a good sense of maybe what's happened in previous grades, of things that you might need to just touch base on with the students and make sure that they know, because they won't have arrived with the background knowledge because they haven't had the privilege of the 6 grades already of doing energy in the new curriculum. Okay, so that's always a consideration for us as well. So we're going to move forward, and for kindergarten to grade 4, we have always put something into our acknowledgement that links the Indigenous perspective to whatever the organizing idea might be sort of focused or centered around. And we had the Grandfather Sevens teachings for kindergarten to grade 4, and for grades 5 and 6 have flipped this into the Northern Lights. So thinking in terms of energy and what creates the Northern Lights, this might be a good place to have that story or that legend told. So if you're not familiar with it, every nation tells it just a little bit differently, but they have, I would say 80% of it is a common thread throughout. So in this particular one, you're looking at it from the Alaskan perspective, and it's a beautiful story. It's not long, very appropriate for grade 6s and grade 5s. It's not too childish for them in any way, shape, or form. But also it just introduces them to the whole notion of the aurora borealis, and really when we think about it from an energy perspective, how that forms, then we also have a little bit of an understanding of where the linkages might be. So we won't play that right now, but just something for you to click on here and discuss with the students. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So as we mentioned, we are going to unpack, oops, it's going to start on us there. We're going to unpack our previous learnings, sort of the big ideas that have already kind of come before, and how those sort of translate into the parts that are going to slide into our grade 6 energy. So I'm going to turn over the initial pieces right over to Ted, and he's going to get us going. And I'm sorry, I forgot to start in case you're brand new. My name is Chris Arski. I am one of the DPLs. Now, I've got this, taken me 7 sessions to get it right, but Designer of Professional Learning. They've changed our titles. And I have the distinct pleasure of working with the best partner, and that would be Ted, and he's going to introduce himself as a DPL as well.
Thanks, Chris. Hi, everyone. Yes, I am a DPL, or Designer of Professional Learning, with the Edmonton Regional Learning Consortium. It's a pleasure to be here with you to try to get a better understanding of this grade 6 energy organizing idea. And we're going to begin that by just taking a look at the big picture. And I mean, the big picture, starting all the way from K to 6. We won't spend too much time on that, but I think it's going to be really helpful to understand the grade 6 organizing idea a little bit better when you can see where things have been. And even getting a bigger picture is that those of you teaching and looking at this curriculum for the first time will know can see it's very different than the old curricula, which is represented here in this graphic. And it's represented by different silos, because essentially that's kind of what the topics in our old curriculum were. They were just silos or or just units of information that were taught separately with very little interaction likely between the different topics that we did, unless it was done intentionally and purposely through pre-planning and taking things apart and doing it. Generally, we taught it as or topic 1, topic 2, topic 3, and so on. And that happened within the grades as well. There was the grade 2 curriculum that was taught to grade 2, grade 3 did their own thing, and grade 4 did their own thing as well, without little interaction between the grades and things carrying over between the grades. When you look at the new curriculum now, that's changed quite a bit. We can take this graphic now and add a lot of some movement between the silos, that by using a conceptual maybe heading such as matter and energy and earth systems with the organizing ideas, we now have information in there that can flow back and forth between the organizing ideas within a grade and between the grades as well. So what we're going to look at really briefly is how is it structured, what's in these organizing ideas that allows for that flow of ideas back and forth. And one of the things is the concepts, the individual ideas within it. I think the best way to show that, how the concepts flow between the grades and the understanding of the concepts grow between the grades, is the next series of slides. So really just as a brief overview, when we talk about energy beginning in kindergarten, the focus is really on movement and the movement of objects and animals and how they move, the ways they move. And that's where the whole idea of energy is born in kindergarten, is with the idea of movement with animals and objects. And it's defined as really a change in location or position. By the time we get to grade 1, we add a little bit more, and we talk about more than just the ways things move. And the grade 1 content is illustrated there in the green. We're talking about direction and the pathways and the speed of movement as well influencers on movement. The notion of force influencing movement comes into a little bit later on in grade 4. But we take a little bit of a pause at grade 2, and we take a look more specifically at light and sound and the pathways and the behaviors of light and sound, and how those paths are affected in different ways and how it travels. So it's when we get to grade 3 that we take a look at things like forces, and grade 3 is where the students are first introduced to force. And we'll see that idea of force and contact forces and so on that's developed in grade 3 continues up until grade 6. A reference is made to those in grade 6 as well. So that's grade 3 is where we're first introduced to force then, and contact forces. By the time we get to grade 4, did I say grade 4 earlier? I meant grade 3. By the time we get to grade 4, we're talking about non-contact forces with an emphasis on magnetism and magnets and gravity. Grade 5 introduces the idea of flight and buoyancy, and how forces affect flight and buoyancy. And there are certain things like drag and thrust and so on as forces that are introduced at that grade 5 level. And our understanding of forces deepened further now in grade 6. And we separate the idea of forces into, if you see, you can take a look at the top part there in the pink, between internal and external forces. So we still look at the external forces and the contact forces, such as the applied and friction forces. But we add on the internal forces, and I see my I have an arrow at the very top. Those should be the forces of, for example, tension and compression and torsion and those kinds of internal forces. And then we also look at how those internal forces and external forces can cause differences in the objects, such as a change in shape. And it all depends on their plasticity and elasticity in terms of permanent and non-permanent shape changes. More specifically to grade 6, in terms of the organizing idea, we're looking at it in this way. We're looking at they do that force can be internal or external, and we have the different ones identified there. Focuses also on that force can change objects either through their movement, shape, position, or size. And the focus of grade 6 in this organizing idea is a focus on how objects can change their shape through different forces. And then, we talk a little bit in grade 6 about Newton's third law, and that the When a force is placed upon an object, there's an action, and that becomes the action force. And there's an interaction with another object, and that object has a force on it, which is then the reaction force. We explore Newton's third law through that. Through every force or through every action, there's an opposite and equal reaction. We know in grade 6, though, there's two organizing ideas, two learning outcomes, One focuses on the whole notion of force and motion and change in that regard. The second part is the whole notion of energy as a resource. And this was introduced in grade 5. And this concept map shows the things that were introduced in grade 5 when it comes to resources. In grade 5, and that's the orange part. So in grade 5, they were introduced to the idea of resources and explored the differences between renewable and non-renewable energy resources and what the advantages of some of them were and disadvantages of them. So they took a little exploration into what those different energy sources are. By the time we get to grade 6, we're talking about energy. If you follow that one of the purple lines down, we go to choice. That energy is a choice, and we choose, and it's just cultures and communities and regions choose an energy source based on certain factors, which are availability, the social impacts, environmental and economic impacts that they have. And each of those different energy sources can have an advantage or disadvantages with one of those factors. Also look at how those energy resources then are managed, and then we take a look as well at the difference between those resources in terms of how some are used before they're being processed as energy sources. In other words, we can use wood for an energy without processing it, but some require processing to be used as energy afterwards, such as fossil fuels. And that's a general look at the two learning outcomes for this grade 6 organizing idea of energy.
And Ted will jump in later and bring this up again, but this visual that you saw here, as well as the one that was put together pretty much right here for the first one, you need to really realize how much of grade 5 has been covered that links directly into grade 6. They're not just here to say these are how they were initially. They actually flow right in the language. Everything they've learned is now to be transferred in. So that's going to be a big piece that we need to keep in the back of our minds when we're doing our planning. And also when you're listening, when Ted's unpacking some of those pieces, are those words or those terms that your students would already know from their previous backgrounds? If you're hearing things from a grade 5 linkage, or you're seeing things in here in the gold that don't fit that, then those are places that you need to go back to, because it's not going to make much sense to them otherwise.
When you get the slide deck, this will be another graphic they have available to you. You may have seen this one before, but it's a similar piece of information that the larger concept maps had. It just shows a progression of those concepts from the different grades. In this particular case, it shows energy and from K all the way up to 6. The bottom half are the key concepts that show up with each of those grades in the organizing idea of energy. And in the top half, we see the guiding question and the learner outcome. So you can see the progression from grade to grade, and it gives you a sense of what the kids or students should have with them when they come to the grade. And of course, grade 6 this year, if you're teaching it for the first time and your students are getting a new curriculum for the first time, there will be a lot of information they will need to bring forward, or some back pre-teaching to do before you get into some of the content of this organizing idea. So it's not only then that the concepts that flow around through those bins or silos, and that's what those pictures are, I should point out. They're not spacecraft or anything, any weird insect. Those are actual meant to be grain silos. But other things move around between the grain silos other than the skills and procedures, or other than the concepts, and these are the skills and procedures. And we see those in the skills and procedure statements, and in the learning outcome, we'll find skills stated in there as well. So the learner outcome for this organizing idea is the verb analyze. So students are analyzing things, and then they're also making relationships. They're relating, in this particular case, interactions between objects. And keep that in mind. Analyzing is one of the sub skills of the larger skill of investigating. And you could see in the first cusp of this organizing idea, the phrase conduct investigations is one of the things that happens here. And this is probably an organizing idea when it comes to motion and moving things and experimenting, where investigations do come in handy. And there's a process that is identified in grade 2 that every grade uses all the way up to grade 6. We'll review that later, what those steps are, so you have them with you and you don't have to go back necessarily to that organizing idea. But you can see a lot of them are related to the whole notion of investigating. And that's really going to be the focus, I think, of this organizing idea for the most part. Now, this whole notion of skills moving from silo to silo and from grade to grade, those similar skills such as analyzing and predicting and describing and discussing, those have been happening since kindergarten. Those are same verbs that are showing up in kindergarten, grade 1, grade 2. So by the time they get to grade 6, they should have familiarity with those. And in other words, because they're transferring that skill year after year to a new organizing idea, to a new grade, to new content. And that really is what we're talking about when we say the things they learned about earlier need to be transferred up, but they can also be transferred between organizing ideas within your grade. So some of those things that help us transfer is understanding the phases of learning. When we first introduce something that's new to the students, we're working at that surface level. And we don't stop at the surface level. We need to give students many iterations or practices at trying the skill or applying the concept in as many places as times as possible. If I can think of the idea of what comes to mind is prediction. It's a certain skill when students predict things. If we just use prediction only when students are doing an experiment, then they don't necessarily get a really good deep understanding of prediction. It's when we use it in many iterations in different contexts, such as making a prediction with a story, or maybe making a prediction in a phys ed class, or a whole bunch of other contexts, that they begin to deepen their understanding of that concept prediction. And then that's where the transfer happens. And if they predict in grade 3 and grade 4 and grade 5 and grade 6, that's when the transfer starts happening. And the same goes with those understandings. They can also be deepened through several iterations, having students apply an understanding to new situations and new contexts until they get to the point where they're independent and identifying those understandings and working with those understandings in new contexts that we provide with them. So in order for that transfer to happen, again, like I said, there are things, and Chris has mentioned as well, there are things that the students have learned in previous grades that may be helpful to keep bringing forward, and to have students reflect on, to see if they are with you on some of these things, because they're useful in understanding and unpacking the organizing the idea that we're with. So Chris is going to take a quick survey of what happened from kindergarten all the way up to grade 5, and then we'll get into some grade 6 stuff.
So when we look at kindergarten, just for starting, and again, it's that if you're hearing something that you go, I'm not too sure if my students know that, that would be a good place to pause. Use this part of the slide deck, or you can go into that grade wherever you've heard that terminology and grab some from their slide deck, because you have access to all of it. So easy for you to go in and just not having to recreate the wheel, just go in and grab what you need. It's not necessary to reteach the course, but they do need some terminology here that's going to be rather important. And you saw objects and properties show up at the beginning on that title page, and that word has come up over and over, and they've learned that in Matter already. We've been unpacking that as we went through even Earth Systems. We did the same conversation. So here we are again, talking about objects and how objects can move. So movement was the starting point, and as Ted mentioned, the definition that the students had in kindergarten. So that was the big idea there, was movement. Like, can they define movement? Can they see how it moves? Can they describe how it moves, the pathway that it takes? But the pathway even gets teased out a little bit more in grade 1, where we start to look at not only just the pathway, but we also look at the object could have speed as it's moving. It can have a certain direction that it's going. And that could be as a result of a push or a pull or some force of energy, or that it's able to do that on its own, right? So this is the key pieces that we wanted them to know from grade 1. So direction, pathway, and speed.
Jog's track loves to go forwards.
The other piece that comes into play is also the shape of the object. Does that in any way change its ability to move or not move? Does it hinder it? Does it enhance it? So without being a mistake, used a cylinder as the information to put our stuff into, but it's also a unique shape in that I have flat surfaces, but I also have a round surface. So I can slide it depending on what the surface is that I'm trying to slide it on, or I can roll it. And again, it might be a really nice smooth roll. It might be a bumpy roll if it's on a rocky surface, an uneven surface, etc. The material that the object is made of is going to determine movement as well, or whether I can even move it. I can push on this rock all I want. I'm not going to be able to move it. Or the texture of the surface that we're about to slide something on or roll it on, or whatever it is we want to do. Does the texture of that surface in any way, or the texture of the surface of the object I'm trying to move, does that influence its ability to move or hinder its ability to move? So clearly the word friction comes into play, and we do talk about that. We don't really define it deeply. They do it in grade 5 a lot, and it's something that inherently would come into grade 6 as well. So we would, there's that kind of transfer up and into where I need to make sure that they're familiar with those terminology. Grade 3, as we saw, they start to talk about forces and what kinds of force, or what is force, first of all, a push or a pull, and we define how we can make those forces happen. We ask them to identify whether it's a push or a pull. We get lots of examples in their daily lives, so we really try to unpack what that looks like. So there's where the word friction comes into it again. The applied force, where there's direct contact. So we talk about contact forces, but more in terms of it being a push or a pull with the touching of surfaces. We use the term applied when we start to get into grade 4, 5, and 6 again. You're going to see contact, non-contact in a very surface level, and it's kind of more of an obvious type of thing. And then we also talk about elastic and spring kinds of motions, and those come right back to grade 5 and right back into grade 6 again.
Hi, kids.
Sorry, whenever we link these, they all automatically turn on as soon as we change our screen. So we also have the opportunity, perhaps, maybe just taking some terminology, and maybe that's where you want to start, is giving the students some of the terminology that's come up already, and this is coming from grade 3. So are they familiar with those words? And what if you gave your students right now in grade 6 these cards? How would they group them together? If they were to make a concept web out of that, like what would they put together? And remember, there isn't one right way of doing that. Again, they would need to know what we mean by finding relationships between them, because that's really what a concept map is. And you saw all those ones from kindergarten to grade 6 at the beginning. So again, if they need a little help and work on that first, we would do the work that's up in the top left-hand corner with them. But this would be a great way for me to find out formatively what they know and what they don't know. And it isn't going to be so much as to how far they spread them apart and where they have them. It's going to be in the conversation they have for why they put these together. Why are these linked together? And that will tell me as the teacher, oh, they've really got a great understanding of this already. Or I'm hearing some really good things. I'm hearing some really good things, but I'm not hearing the full picture. So you can kind of find where the holes are that we can start filling in and start building some further knowledge on. So we can give them a sample of what it might look like. Again, it doesn't have to be this kind of conversation or this kind of connection. It would be up to them to sort of justify why they put things where they did. And sometimes just talking it out, then it helps them to find that, oh, maybe this isn't the right place for it, right? So they start to talk to themselves and hear themselves say why they think it belongs there, and it doesn't, or it does. So here's a sample of some of the ways that some of the terminology that we learn in grade 3 could fit together. We move into grade 4. We talked about magnetic and gravitational forces, and although you see a third one here, the electrostatic, it's not actually one of the ones identified for grade 4. However, it was part of the picture that we had, but it also kind of fits very well in, and most students have had an opportunity to take a balloon and, let's say, rub it against their hair, and they get static electricity and they think it's really cool. We can just talk about that. We don't have to get into the technicalities of it, but just to mention it wouldn't be a bad idea. But the two that they really unpack are magnetic forces, repelling and attraction. We learn about magnets, we learn about how they work, we learn about what we can do with them, we learn about what attracts to a magnet, what doesn't attract to a magnet, all those pieces. And then we also talk about gravitational force. Why is it when you throw a backpack on the floor, it stays on the floor if it's on the table or on a chair? What are the forces that are holding it in place? And those are examples of contact forces and applied forces, because the two objects are touching one another at the same time. So those are pieces that we unpack in grade 4. This is one of the examples that we gave. So the backpack sits on the table, and we see that definitely there's an applied force here, but there's also that imaginary one or not imaginary, but the one that's invisible that I can't see, and that's gravity. And so children may have heard about gravity so far, and they might know that it exists, but if you said to them, can you tell me what it is? That's where they might falter. They might say, I don't actually know how to explain it. So that's the next piece that we would unpack, and we would want them to know what that is. So what is gravity? Okay, we want them to not necessarily just have a definition on the board. We want them to really unpack this. So the way we unpacked grade 4 was to provide them with things like maybe a video, maybe it's a book that we read, maybe it's a model that I'm demonstrating. And it's from those that we start to glean the information we want them to learn about what is a magnet, what is gravity, and can they start to frame together their own kind of definition. So it isn't about putting a bunch of definitions on the board and having them copy them into their books, because that's not transferring anything other than physically transferring it to their paper. The pieces that we're starting to see in 4, 5, 6, and you're going to find it very much in grade 6, is your knowledge column is very content heavy of definitions. And it runs the risk of us just doing that, right? Just putting something on the board and defining it, giving them one example, holding it up and saying, let's move on to the next one. And that really is, first of all, not engaging for the kids. We're going to lose them along the way, but that doesn't necessarily mean I even understand what you're talking about. So if we can find other strategies and modes that we can go into that might help us to engage them to get the terminology out of the activity as opposed to the other way around. Okay, just a thought. Conducting an investigation, you saw Ted show you that investigate is a huge component of this. Can they find out what they've learned? Can they find out how, for example, a magnet works? Did they find out which ones were attracted to the magnet, which ones weren't, etc.? Done through an investigation. And so again, filling in maybe a table or a chart to start with, but if you look at some of the terminology you have, there could be a lot of tables and a lot of charts. And again, that just becomes a redundant process. So thinking outside the box, like what other things that we could do. But that whole notion of an investigation is really important. It gets unpacked in grade 2 in its perfect state for scientific method, and Ted will address that again. But they really need to know that well. So you might want to take them through one of these processes. Anything you want to add there, Ted? Okay. We also talk about Earth. Earth is a big magnet. It has a North Pole and a South Pole, and how does that work? And we talk about magnetic fields, right? So we unpack a lot of those pieces as we're learning through in grade 4. So then going into grade 5, again, they had 2 learner outcomes. So there were 2 sections, one that had to do with force, one that had to do with energy. But both of those would be, as Ted mentioned, transferable. We need them to know what they did in grade 5, because you're just going to start talking as if they know it in grade 6. So there will be a need maybe to have a real good look at what is it that they did in 5, and where do you think your students are at when it comes to some of the language and terminology and some of the concepts that were being unpacked. So flight was one of them. We were talking about flight and buoyancy. Figuring out how is it that a big plane like this can take off? What are the enduring factors that help us, what kind of forces help us to get that plane off the ground? And why does it stay in the air? Why doesn't it just drop and hit the ground instantly? So we talk about all of those different pieces. We talk about the gravity, we talk about lift, load, drag, thrust, all of those pieces. We give them lots of ways that are suggestions in the slide deck that you could do with the students for how do I teach them, what that might look like. So one of the example is if they're driving along with parent permission and they're going down a highway, put their hand out the window, and if their hand is fairly flat, they're going to feel the air coming over their hand without question. But all they have to do is just tip their hand up a little bit to find that force of the wind against their hand pushes their hand back, and they have to forcibly hold it in place, which is really the same idea about how we take off in a plane. So learning how to do some of that, we learn about opposite forces. So lift being the opposite of gravity and thrust being the opposite of drag. And what do those mean? And how do they affect things? And then what happens if I change the conditions of them? Talk about buoyancy. How is it that things float? How is it that I can have a really small plastic thing float on top of a kitchen sink water? And if I were to take a knife and it drops to the bottom of the sink, then why doesn't that happen with a super tanker that's carrying oil? Why doesn't it just drop to the bottom of the ocean? So again, we talk about those factors that are in place and that help with that. They do lots of investigations, hopefully. And if you can't do the investigation in class, there are no shortage of online demos that you could use just to engage, if nothing else, the students in what we could be doing. And then we can have that discussion around it.
In this experiment,
So same thing with buoyancy. We talk about what it is. We talk about how things float. We talk about just the fact that we need to have balanced weights, what makes it float, what substances can I
Topic
Most of us have
buoyancy.
seen an aircraft.
And then we talk about the concept attainment. What are resources? Ted, do you want to address that one?
I'm going to address the investigation piece and this resources one as we move on to the other, to the grade 6 part. Yeah.
Okay. So then we also talk about where do we use energy? And we know that we use it every day, but sometimes maybe not explicitly thinking in terms of energy that I'm using. So after they've learned a bit about that, what kinds of places do we have some resources? Where do they live? Everybody who's watching this video comes from a different part of the province. So some of you might be in a small town, some of you are in a big city, some of you are in a countryside and have very little of a population around you. Sometimes it's just the school and maybe one or two buildings, whatever. Okay, it doesn't matter where you live. It's what resources would you have around you that you would be able to have a conversation with the students to say, these are resources that serve as energy. Maybe not directly for us, but what are they? What are some possibilities? One of the books that is a really good little book to have in the classroom would be this one that is called Energy. And it has, just by virtue of some of the things that are in the table of contents here, you can see what they talk about. And it would work really well for grade 4, 5, and 6. This is a wonderful little book in the sense that it gives us a good overview, not hard, not too childish for the students to read, but gives us some good succinct kinds of models that we might want to discuss. So if you're looking for something that would be small, just to add into your school, your classroom library, this would be one. If you have the sales series in your school, then you already have this book. This comes from a Pearson resource. Sales has been around for a long time, so you may already have it in your building. Canada's energy is as in terms of a research, rather than me telling you what kinds of energy we have, why don't we turn it over to the students to do a little bit of research, to find out some information and bring that back. And that might be our starting point. So again, I'm trying to sort of navigate the waters of lots of terminology that we need to learn versus doing it from a different side and having it come at the students from an engaging way rather than simply a definition on a board type of thing. So consider maybe a case study. Maybe you pick 2 resources and you bring some information in and you read them about those 2 resources. And what are the things that they have in common and what are the things that are very different about them and where are they located and what would they be used for? So unpacking those 2 then allows me to set up maybe what I would expect them to do if they were to pick 2 of their own and do that same kind of a comparison. Okay, so there's a suggestion here that you might want to do, or that we had put forward for the grade 5s. What are the different kinds of energies? Maybe the students don't even know what they are. Maybe they just want to pick one and they get to go and research it because they don't know it. This would be part of grade 5. But again, if my grade 6 students aren't familiar with a lot of these, then that might be my starting point, is using a slide like this where you have individual small videos. Each person who's doing different ones could just watch that overview and do a little bit of their own research. They're certainly old enough to do that now, and to come back with some information based on what it was you were asking them to do.
Hydropower.
That was a lot. One of the other sources of information that we have is there is a section or a site called Core Knowledge, and they provide teachers with a teacher's guide and a student resource that we can download in form of PDF. They are freeware, so you are able to go in and grab them if they work for you. There is one for the grade 5s that worked really well, and it actually links into grade 6 as well. When you go into the student resource, it's usually about 25 pages long, and I'm not suggesting that you have to use these. All this stuff is just samples that you could use if you need something, or you could just take a couple of pictures from that student resource and use that for discussion or teaching that you want to do. The teacher's resource is typically 100 to maybe 150, sometimes even 200 pages long, which includes not only the explanation of the teaching components, but some ideas for activities, some ideas for investigation, some questions that you might use for activities within the classroom as follow-up to investigation, etc. So I encourage you to have a look at them. Everything that's listed here is what you will find in these 2 resources. So these are hyperlinked for you as well. So let's look at grade 6. I'll let Ted take it away from there.
Thanks, Chris. The way we've been working with all the organizing ideas these last couple of rounds, including the series of energy sessions from K2 to 5 and now grade 6, is starting by looking at a focus on the learning outcomes and the understandings. Because at the end of the day, those are the ends. Those are the things we really want students to walk away with, are those understandings and that are reflected in the learning outcome. So to begin planning, when we're thinking about, well, what do we teach at the surface level? When do we keep practicing to deepen their understanding at the deep level, so we know that they're ready to transfer or to have an assessment? We have to do some of that backwards planning by looking at the big picture, the end, or the outcomes and understandings first. So that's what we're about to do. So the next slide, I think, Chris, we'll have to just, it says surface, but we'll have to skip past that one. So before we get to the surface level, we have to decide what is it they're going to need to teach at the surface level. And the learning outcome and the understandings are going to help us to do that. You could say, I pointed out there, for example, students analyze forces and relate them to interactions between objects. Well, that's one of the things that we're going to be assessing students for. So let's look at that as the big picture and go to the next slide. If we're going to create an assessment for that, we're going to need to know that students are going to need to know what analyzing means. What does it mean to relate? What's a relationship? And then they're going to need to know some interactions. They also need to know a lot about forces. So when you look at the graphic below that, so at the surface level, students should know what analyzing is, and they should probably have a deep level by the time they get to grade 6 if they've been through the system for a few years. And what does it mean to relate? I also highlighted on the bottom the concept of interaction, plus the forces of internal and external forces and all the other forces that were looked at in grade 5 or 6. Chris is going to share with you some surface level activities for those forces and how they work together and so on. But I just want to point out to you the 3 links that I have there. Those links are there to help introduce at a surface level, what does analyze mean? What's an analysis? It really is one of these steps in the investigation process, which we'll look at in the next, when we take a look at the next learning outcome. But for this one, we could just focus on analyzing and relating. What does it mean to relate things together? Relationships can be cause-effect relationships. Relationships can be dependency or independence. There's all kinds of relationships that exist between objects and things and people and things. So that's what those two activities outlined for you. And the one below, it talks about interaction. You can see the word interaction. We're supposed to analyze interactions. Well, what is an interaction? And that is a surface level at the bottom, a concept attainment activity that you could use to introduce students to the idea of interaction and what it means. So it's because the word interaction shows up many times actually throughout the K-6 curriculum. I think this is the only instance, though, Chris, where it shows up actually in the learning outcome, but it's in many of the skills and procedures things. So it is an important skill or concept to know, but it's also likely that students already know this. If the students have gone through, after a few years, they'll have gone through the students coming to you will have gone through the new curriculum. They should know what interaction is. They should know how to analyze, and they should know how to relate. So that pre-assessment for all these things at the front end is really important. And that's going to help then set up what you're going to need to teach at the surface level. If they don't know how to analyze, they don't know what interactions are, or what any of the forces are that are listed there as well. That's where if they should know them, and they don't after the pre-assessment, they're part of the surface level teaching as well. So Chris is going to share with you some of those activities that'll take you through that surface level of forces.
And so the slides that you're going to get now are just that. They are surface level. They're resources, trying to find things that you don't have to surf the web to find. So here are places you can go and grab some information. Now, whether the students are going to get that slide and they're going to do the work and come back and tell you what they've learned, or whether you're going to use that as an instructional component for the whole class, that's your call. And you kind of have to map out, what does this look like for you? How do you best see this being all unfolded? And then you go grab from here whatever works for you. But the very first one is just a review of what forces and motion are. So if that's a starting point for you because you're not sure what they remember, this is a good one for them to start with. One of the other slides that I pulled from the grade 3 and grade 4 is this one on contact forces. This one comes from grade 3. But again, if I don't know what a push-pull is or an applied force, then maybe I need to just watch some of this just for, if nothing else, to refresh my memory. Again, these are all just very short, but they are concise enough to tell me, what is friction? What does that mean? What is a contact and a non-contact force? Just what is the general descriptor of it? They give examples, of course. And our hope is that when they're watching this, that anytime you ask them a question, it'll always be, can you give me one that's different from what we've talked about, different from what you saw in the video? So always just nudging them to think beyond what they've already seen, heard, make the connections, and go from there. The same thing with internal and external forces. So part of that is a carryover from grade 5, because they don't really frame them necessarily in those terms, but it is from there. So again, what is defined as an internal force and what is an external force? Equal and opposite reactions is what we're talking about. So again, and what they're going to be unpacking are applied, friction, tension, elastic, compression, shear, torsion. Those are all terminology that they need to unpack here and be able to recognize in different scenarios. So again, it runs the risk of this has got to be more than just what a definition of each one of these is. I need to really be able to find it as a student, that you give me any example by the time you want to give me a mark at assessment, you give me any example, and I have enough background knowledge to tease out which one of these forces I'm starting to see and give you a rationale for why I think that's to be true. So the same thing with this one, external forces acting on structures. That's something, again, depending on where you live, that might even make more sense to some of the students.
Hi, kids.
Chris, before you go to the next slide, can I just add something to that slide?
You bet.
Yeah. And again, if you look at the wording on the slide carefully, like look around your surroundings and find these things. And then there's another, identifying external forces acting on structures. So those are, again, the ways when we're talking about moving from surface to deep. It's giving students all those different contexts. So look around, to apply, to see their world, to examine the world, and see those concepts of friction, tension, elasticity, compression in the world around them. And when we talk about different contexts, this is exactly what we mean. Their surroundings, readings, different videos, and so on. So sorry, Chris, I just wanted to point that out.
No, no,
That's how we deepen those understandings and those concepts.
So another one, and this would be getting really much more into the grade 6, talking about internal forces. And now we are talking about the terminology that centers around what we're talking in grade 6. So compression, and this is going to model for them each one of those. Tension, torsion, all of those. So it'll be important for students to really have an opportunity. And I would even say, excuse me, to pause the video after each one. So if we're going to talk about compressions, let's do that. But then let's stop it and see, where do we have for models or examples? What do they have that they can name that would be a good example of that? And just not be in a rush to necessarily watch that whole video. Forces again, another way that I might want to think about that internal and external forces, even just picking up a milk carton, right? Or a juice box or whatever, like whatever you want to use here. But what are the forces that exist when I hold the carton on the side? What are the forces on the contents that are inside? The force of gravity on the bottom. I have it sitting on the table. Like all of those conversations, that's all part of something as simple as a little juice box that might have been in their lunch kit today that's sitting on their desk, right? We can have that conversation. Taking a balloon that might be filled with water, and I can take it and squeeze it in the middle and I'll get 2 bunches on each end. So again, what's happening there? So what are the forces that are acting? So having them just have that opportunity to try and see different things that they might do for fun without even realizing that these are in fact all examples of the things that they're doing. So reviewing all of the forces that we've done, this is 1 or 2 of approximately 10, I believe it is, videos that come from a section called the Physics Classroom. Now, not every one of those would be appropriate for grade 6, but there are more than what I have on the screen here. But these 2 in particular, this one reviews forces in general, like including grade 6, but this one is really focused on Newton's third law. And very well done. In some cases, you might say, oh, they've got a couple of words in there that aren't really in my curriculum, and that's okay. It's all right for them to know that they exist. We're not going to assess them on it. But everything that we do in grade 6 is definitely in these videos. So again, you need to kind of go through them and see what elements you're looking for.
Welcome to the...
Depending on how you're going to structure your... So another one would be, what's the difference between elasticity and plasticity, right? They probably know elasticity. That's an easy one. Elastics, they're familiar with that kind of thing. But they may not be thinking in terms of plasticity, right? And what that means. So again, what's an example? If you've got examples in the classroom that you can use, great. If you don't, then we need to find some or model it through a video. So, you know, if you take a sponge and the sponge is wet and it's got water in it, I can take the sponge and I can squeeze it in my hand, but when I open it up, I still have the sponge. It bounces back again, right? What's the difference between that and something where I would take it and I would squish it and it doesn't, it changes its shape. It doesn't bounce back again. So having, again, those conversations about those, and these get into those properties again of an object. What properties does it have? Is it an elastic property or plastic property, right? Plasticity. Okay, we get into some of the deeper level activities. Oh, we're going to skip over into this one first. Yep. Oh, you're muted, Ted.
Yeah, sorry, Chris, if you just go back to that deep slide, there's a slide missing there. So if you go back one more. So again, when we're talking about deepening the understanding of these of the forces and the concepts and ideas that Chris is talking about, the surface level, again, all those examples in those different contexts are going to help students to deepen their understanding of those different forces. Giving students those diagrams, for example, of the person squeezing the ball, and you saw, or the balloon, and you saw those arrows there. Just giving them that and having students to identify the forces, what do those arrows mean, is a deep learning activity, because now they're applying it and they're looking at it and trying to apply it to a new context. Or the milk carton thing, or give them a video of something or a picture of or a little event of something. Say, look at what are the interactions happening here, diagram an interaction and identify the forces with arrows in that interaction would be another way to deepen that activity or to assess them at that deep level to see if they would understand those forces. Sorry, Chris, that slide's not there.
Is that slide there? I should just refresh, or
yeah, but it's just a written out one, so not to worry. But if you want to do that, go ahead. It is there.
okay, let's just refresh, so then we'll have everybody on the right page so you can see it.
So yeah, it's just finding different contexts where you give students an opportunity to see a force and then having them identify it and diagram it out. And when they diagram it out and put in the arrows, again, they're demonstrating to you their understanding. So.
And remember that any of the deep levels that we have here could also be formatives, depending on where you're at and how much you've done with them. That doesn't mean because we had it on the slide deck and called it a deep, you might have done a whole bunch of other things with them. And that question comes up and you say, oh, that would be my great transfer. Like maybe that's the one I'm going to use for transfer. So I'm not necessarily stuck on where they belong here.
All right. Now the second outcome goes back, like in grade 5, to energy and energy resources. And you can see the outcome is that students investigate energy resources and explain factors that influence their use. That's quite interesting, the word investigate, and that they use the word explain in the learning outcome together. And it does make sense when you take a look at the investigation process for grade 6, which we'll take a look at the next slide here. So when we do look at the learning outcome, we see and two key verbs there, investigate and explain. It's not highlighted there, but it should be investigate and explain. And we take a look, Chris, I'm going to have you open up the link that says K-6 investigation progression. You see, it does make sense there. Now, this is not everything that is in the scientific methods organizing idea. It's just the focus, pulling out things mainly related to investigating. And when you take a look at grade 1 on the left, there are 4 steps there to the investigation process. And those 4 steps are expanded to 7 steps, I think, by the time we get to grade 2. So if you could just scroll down to the grade 2 one. All right, 7 steps, which is asking questions, making predictions, planning the investigations, making your observations and recording the data, analyzing the data, reaching a conclusion, and then discussing the observations and conclusions. Those, you see the yellow arrows actually move into grade 3, grade 4, grade 5, grade 6. Those same steps are the same. What happens in scientific methods is that there's a different emphasis on different parts of that process. So in grade 2, or grade 3, there's an increased emphasis on data and what does that mean? And introducing things like accuracy and objectivity into the data. By the time we get to grade 4, we're taking a look at data and how data becomes evidence. So you'll collect all kind of data in an investigation, but you're only going to use some of that as evidence for your conclusion because some of it may not be, you've gathered data that won't necessarily be helpful for your conclusion. And then you can see in time we get to grade 5, we're talking a bit more about bias in the whole investigation process and introducing the controlled experiment of how now having variables. And you can see how in the energy organizing idea, the idea of having an experiment with a controlled variable really comes into play. So by grade 5, they're starting to do those kinds of experiments, which could continue on to grade 6. In grade 6, it's all those steps, plus there's an emphasis on explanations, and that's the big word highlighted there. Explanations help to explain the data and the conclusions that were found. And so there's some things there to look at to help with explanations if it's in the learning outcome. So it probably isn't a mistake. It's probably not just coincident that they're having students investigate something and explain it in the learning outcome. So those are the progressions. How might you unpack teaching the investigation process is something that's there for you as well. if your students still haven't seen haven't done an investigation yet using those steps, you don't have to open this up, Chris, but there's a steps to the investigation link there in the yellow box. And what that allows you to do is teach the steps in little chunks. First of all, there's lessons in helping students understand what a prediction is, an analysis, observation, and then there's some activities that you can do to put the steps together to do some mini investigations that are fun and not necessarily related to anything with organizing ideas. So you just practice the skills and the procedures of doing an investigation. This investigation or this organizing idea or learning outcome can also be, your students are probably going to have to do a lot of research in here. Or if they're going to be looking at factors that influence their use, they're likely going to have to research that. So there's a rubric there under research skills that pulls out some things that students at the grade 6 level should be able to do at research. And they may have to be taught independently. For example, citing sources is one of them, using a variety of sources. And those independent skills, if they don't know how to do those, again, be something that you're taught at the surface level before you really let them loose on their own and doing some research. And finally, they are going to be doing some decision making, likely with this organizing or this learning outcome, because they're going to choose perhaps or justify or rank order energy resources that should be used, or which ones they would select if they could select one to use. That's going to involve some critical thinking and problem solving. And so there's a rubric there that can outline some of those critical thinking and problem solving things that students should be able to demonstrate as they do any kind of research and then make a decision about which energy resource may be the best based on those factors. So there's some introductory stuff. Once again, in this organizing idea, students should probably be reviewing all the different energy resources, whether they're renewable, non-renewable. The key big thing that's probably new with this organizing idea are the factors that influence our selection of energy resources. So there's going to be some pre-assessment for prior learning to what they know. They may know a lot of this stuff already, but we'll find out in that pre-assessment when you do that. And then we go into the surface level teaching if they don't, if they're missing some of those pieces. And so Chris is going to continue on with some things to introduce to the surface level as well.
And that'll be important for them to, in this first year in particular, for you to pick up some of that terminology from grade 5. So just reviewing sources of energy. Some students don't know what hydropower is. They don't know some of the terminology around energy. They may or may not hear it. Some of them may hear news flashes and whatever. But again, just to make sure that they know where we get some of those sources from, what solar is, then you might want to just start with something like this. And again, finding out from them where they're at. In grade 6, we're also working on what is a source of energy that's unprocessed. So for example, if I want to have a campfire, I have a source of energy of heat right there. I can just start a bonfire with wood that I can find in the bush. And I don't do anything with it other than make sure I can just get it in the fire pit. I don't have to process it to do anything to gain the energy that I need from it. Whereas other things, I can't use them in the form that they come out of the ground or out of the surface of the ground or wherever I find them. I have to have them processed in order for them to be usable in forms of energy. So they learn the difference between unprocessed or before processing, and what do we mean by that, first of all, and then what are some examples that they can think of, and then what are some things that maybe we can add to that as we start to unpack the different energies. An introduction into resources. Ted, do you want to talk about the introduction to resources?
Sure. Just you can click on it really quickly if you want, Chris. It just goes through what Chris just said. It just provides a little bit more clarity with a couple things. Perhaps what this does, it goes on, it steps back further and doesn't get right into energy resources. It talks about resources right off the bat, just what's a resource to begin with. And so it introduces the idea of a resource as just something that we use for some purpose. So when you look at all these, you ask students to sort them, for example, as an introduction. Students may sort them as with the eggs and the shoe and the pen because they're not broken or something. And then that blob and the apple core and the broken skateboard might not be, might be in a different category. You go to the next slide, Chris. Then we start looking at grouping them. So maybe someone sorted them like this, which would be a shoe and the pen and the eggs, versus the broken things and unused things. And that's where we can introduce the idea of resource. That why would someone group them this way? Well, they're things that we can use. Now, of course, we're getting into some gray matter here because some people may see the skateboard as the resource, right? I could take that skateboard and take the wheels and use it to make something else, or I could use the apple core and I can compost it, make fertilizer, or part of my fertilizer process in my garden. So it's certainly the idea of resource is going to be dependent on where people are at and what they do use. But this just introduces the idea of resource. Then we don't have to go on, Chris, but I just wanted to give you a flavor of what's in there. It talks about then what is energy, period. We talk about energy with students, but what is energy? So a little bit of talk about what it is. And you can click out of here, Chris, if you want. Back to the main deck, but it does cover other concepts, all those things such as what is the renewable, non-renewable resource, what's the difference, and then examples, non-examples of processed, unprocessed resources, and then getting into the energy resources, and then also distinguishing between processed and unprocessed energy resources. So it takes the stuff that Chris had in the front slide and just adds them together in this other little packet of slides. So.
And again, if I don't know what those kinds of energies are that I'm supposed to be unpacking in grade 6, each one of these has been hyperlinked for you, and their format is identical. It goes to one of the sources, which in this case was Solar Reviews. And what they do is they describe what it is. I don't know what biomass is. I don't even know what, and they may not even know that they actually might have it being used around their area. So what is biomass? How do I define it? What are the pros and cons of having it? Is it expensive? Is it something that harms the environment? Every one of them goes through very similar kind of subtitles in each one. So now if you are going to ask me at some point to make a decision or defend myself about which one I think is the best, I have some background knowledge, and that's important. We can't just define something, but then not give you enough tools in the background to be able to make decisions about which would be the best one in your area, or which one is in your area, or whatever. So every one of these has been hyperlinked. And again, would every student need to do that? Maybe not. Maybe they do a comparison. Maybe they do a group presentation, like whatever, however you're going to unpack that. And then the same thing here, these are hyperlinks directly to Alberta and Canadian government. So they give you sort of updated information about the types of fuels and the types of energies that are available. Again, that would be something that would help a student unpack some of the understanding from each one of these. So as I get into deeper ones, I need to know what are the factors, right? That's an important piece. First of all, what is a factor? You need to know what a factor is, and that might come up in math, right? When they think about the factor of 6 is a numbers that go into 6 or that create 6, 2 times 3 or 1 times 6. So what are the factors? What are the elements that we have to consider when I look at, if you said to me, which energy would you think is the best for your town or Alberta or Canada? Which one would you choose and why? I need to know something about that. So again, those elements that we just unpacked on that first slide would be one, but here are some things that they should be able to articulate and start to consider when they're making their decisions. Like, what's the availability of that source? What's the accessibility of it? Do I have to extract it out of the soil or out of the earth, or where do I get it from, right? Is it a mountain thing? I take a mountain down. Is it efficient? Is this something that's going to cost us more to try and create than it is anything else? Transportation, distribution, societal impacts, and so on. These are all factors of things I should consider when I'm looking at different sources of energy. So a little bit of a definition up on the side here. You could even do some of this with a card sort. You could give them a card sort that has some of this terminology, even some pictures, and you could have different kinds of energy and ask them to sort based on that. You know, this is an efficient one, readily available, sustainable, whatever. So having different kinds of terminology on cards where they can do some sorts, and then maybe they can see that in their opinion, based on how they sorted things, this particular energy sort had the most cards. And is that the most benefit, or is that the most negatives, right? Then we look at what we put what cards we sorted. So again, there's lots of different ways that they can learn this information. which is the best energy source? That would be my suggested sort of assessment that I might use at some point here, whether it's deep or transfer. So what factors are going to influence the selection of energy resources? Got the 4 bullets there. That's kind of a summary of that wheel that you just saw. Based on the research of different types of energy, what are the pros and cons, and which one would be best for their town or city? Maybe they have a best already, and now they can justify why it's there, or maybe they don't, and they would make a suggestion. You know, maybe they think that we should put solar panels and use the energy generated by solar panels to run our town. What is the reasoning? What's your background? What's your understanding? And then part B would be assume that your energy source that you recommended in part A, so whatever I've decided, let's say it was solar panels, is in use in your town or city. Provide 3 examples of where that energy is used in day-to-day living. So now make it real. What is it powering? What do you use? What do you personally use every day where that is driving the energy that you're able to use it? Okay, that's not a very difficult one. Describe what responsible management of energy is. Is it okay for me just to take all that I need and not worry about what happens? Is it okay if I dig up the soil and pull out all the coal that's in the bottom? Or do I reclaim the land? What does reclaiming, what does land reclamation look like? And is there something that, do they just dump the soil back on, or is there a plan that goes with that? I think a lot of times students don't realize that there are very distinct plans that go along with that. Again, another source slide of just information. If you're looking for a little bit more in-depth kinds of things, you can use the engineering from the Ignite team. That's a good one. Just Energy is a great site as well. And the project learning tree, that's a great one because it also gives you little books that you can use and some information in there. Again, I wouldn't use all of these. You have to kind of decide how you've unpacked or framed your unit and then go find what you need to find from there. If I need a little bit of this one, this is a great summary one. I would even use that just as a summary for everyone. Just what is Renewable 101? Just do they know what those mean? Wind turbines. Now let's use what I learned in grade 5 about my plane lifting. How does wind actually move these huge metal arms? Like what is it that's driving those? And so what are the factors that we learned in grade 5 of forces that are moving these wind turbines in order to generate some energy? So again, it's a link and a connection. The NEED project is another one. It's got lots of resources that are built in there for you already. Great place to look. So again, you have to spend a little bit of time just looking through what we're providing you here, and you probably have enough then to at least get started for sure. And then Bill Nye, the science guy, always entertaining, always informative, and he talks about renewable energy. The link here is not a YouTube link, so you'll find it's in the middle. That's why you see the word link. So when you do click on this little triangle, it will still work for you. Possible transfers. Have you done any baking lately? Let's talk about how does kneading dough change the characteristic? What happens when I knead dough? What's happening in there without getting into the chemicals? How is that particular substance changing? What energy is being built in there? How come it rises when I have yeast in there, right? So just talking a little bit about that. How can car compactors or garbage compactors be considered cost savers? Why do we think that might be a cost saver? And some students might argue it isn't a cost saver. Okay, well now you need to take a stand and you need to make a decision on how you're going to argue that, right? And how do they work? And what other ideas do they have that might make efficient energy sources or being respectful and aware of their surroundings to make sure that it's a safe, long-term place. What about if we ask them to design a city? Could you design an energy efficient city? What energy would you use? Why would you use it? Remember, you're going to have to really convince whoever you're going to present that to that yours is the way to go. So they could even make a mini model, right? And what are some forces that they might need to consider? And what are the things that they see? So these are just suggestions of what things they might consider when they're building a city, but this is not the final project. Anything you want to add in there, Ted?
No, at this point, no.
Okay.
Although it is a good design project.
It is a good design. Yeah, you betcha. It's a definite computer science one. And after students have researched the factors that influence energy, here we go. We can have the great debate. I'll turn that one over to you, Ted.
For sure, there's just so much information in this organizing idea, especially with the energy one, that it's easy to get bogged down on doing something like the representation thing, where it's pretty, an independent work where they could do an essay, a slideshow, an infographic. Campaign's not a representation, that should be a little more on the other side, but more of an active one. But this really opens the door for a debate. It's certainly an issue that kids will have opinions on. But when they do their research and they look at all the factors, number one, they're going to be armed with some good information. Number two, I wouldn't do a debate with a class without breaking it down and maybe practicing for several times beforehand with some mini debates, but even breaking down what are some essential things students will need to be able to do in a debate, and just practicing those little sub skills once in a while, like in the investigation piece where you have kids practice analyzing information and doing those little sub skills first before we put it all together in one big debate. So if you're going to do this as a perhaps an assessment piece at the end or a project at the end, you want to make sure that this isn't the first debate the students have ever done. You want to lead up to this at very surface level things, little skills to practice before they get into this, even something about, listening and respecting the speaker, not speaking out of turn, those kinds of things. So just little skills that help make a debate really powerful when they do engage in one.
So a couple of books then, again, if you're trying to grow some of the resources in your in-class library or share with your librarian, that fit really well with your age group and the topics that you're going to be unpacking in this particular organizing idea. Wind power, geothermal energy, these are both scholastic books, as are solar power, water power. These are actually comes in a set of 4. And they're great. They really do give you a lot of information that the students can use if they're doing a little bit of research. If we look at Max Axiom, there's another one from Capstone. These are the ones that are kind of written like a cartoon, but they're very much at grade level and very scientific. There's nothing childish about them, for sure not. One called Renewable Energy, and it's a way for them to sort of learn about renewable energies through the storyline that goes through this magazine. Powered by the Sun or Fossil Fuels, also timely for this particular unit. And then we also have a section in here. Remember that Ange Deering, one of our colleagues, is also looking at embedding for you computing science. So if it's not something that you felt comfortable with, not familiar with computing science very much, what she does each time is she creates a video from a slide deck that she creates for you. So there's the slide deck right here. There's the video. And the slide deck has activities in it that link specifically to this organizing idea and to your grade. It's not generalized for all of the grades, it's just for grade 6. So if you see something in her slide deck in the activities that she's doing or that she suggests, you're more than welcome to use them. And you can follow up with the video that she explains all the pieces that go along with that. And that, my friends, takes us to the end of this. And wow, we're 3 minutes over. We didn't do too bad this time for the amount of information that's in your organizing idea. It's a big one. You need to have some time to unpack it, but you really have to think ahead of schedule how you want to unpack it. The how is almost important as the what you're going to unpack, just to keep them really engaged and to really give them opportunities to connect the different pieces that you're going to teach them or that they're going to be exposed to. So this is our last one before we see you again, and that will be after Christmas. So although it seems weird that we have green grass outside and not bundling up to -50, it is no snow. We do want to wish you a wonderful Christmas break, because that is coming up not too far in the distant future, and that you deserve a well-deserved relaxed break. Take the time to do that. And then we will see you again, I think it's at the end of January, that we will be doing space. And then just a reminder that after space, there are 3 full days that have been set aside, one for grade 4, one for grade 5, and one for grade 6, times 2, because each one of you gets 2 full days, to work on assessment. So if that was an area that you wanted to work on ahead of schedule, then you might want to pick the grade that you are working in, whether it's grade 6 or if you're going to be doing a different grade. Those are going to happen in February and in April or May again that we meet. So we're going to have 2 full days of planning and working on assessment that you'll be able to take for either grade 4, 5, and 6. Okay, I'm going to stop the recording. So if there's any questions. Ted, anything that you wanted to answer?
Just only one, Marilyn. This will be posted online and on the ARPD site fairly soon. But well, probably not till next week, but it'll have the slide deck and this video to accompany it. So if there's something you saw on the slide deck that you want, unless you need it really urgently, we could probably get you a copy for that. But if you can wait till next week till it's posted, that would be better. So if you need one now, let us know and we'll get it your way.